All right, welcome back. Okay, so let's take a look at a couple of limits. So let's take the limit as n goes to infinity, n cubed over n cubed plus 1. Okay, so now we actually know how to deal with this based on just algebra. Okay, you could do this in a college algebra class. Factor out the common term n cubed. So you're going to get the limit n goes to infinity, 1 over 1 plus 1 over n cubed. And as n goes to infinity, that's going to go to 0. So this equals 1. Okay. We're not really going to do epsilon delta or like epsilon n type thing. So it's not like I'm going to say, okay, let's find n given the epsilon. We could do that, but we're not going to do that in Calc 2. That's not really a Calc 2 type of question. Okay, but this is what we just did. Okay, let's do another one. Maybe it's a good challenging Calc 2 question. Let me give you a hint if you did decide you wanted to look at that. Okay, I would do the division. N cubed over n cubed plus 1. You're going to get 1 cubed plus 1 minus, so I would write this as the limit n goes to infinity, 1 minus 1 over n cubed plus 1. And then if you know epsilon, you would make this less than epsilon, okay? And that's how you would find the appropriate n, okay? Just in case you were looking at that problem. I don't know why you would be looking at that problem though. Okay, let's take the limit. N goes to infinity. N cubed over n squared plus 1. If we tried to play that same game of dividing by the n squared, we're going to get, okay, that's the same game of dividing by the highest power of n in the denominator. That's the way you play this game in college algebra. And we can play this game here too. Okay, so we're going to get n over 1 plus 1 over n squared. So what's going to happen? This is going to get much, much bigger, right? This is still going to go to 0. So this actually is divergent to infinity. Okay. All right. Let's take a look at another couple. Okay. We're going to take the limit as n goes to infinity. This is actually going to be a very sort of important point of 3/5 to the n. So now, if n's going to infinity, let's just think 3/5. Okay, that's fine. If we multiply 3/5 by itself, what do we get? 9 over 15, right? 9 over 15, is that bigger or smaller than 3/5? It is smaller than 3/5. And actually, no, it's the same as 3/5 because I screwed it up. 3/5 squared is 9 over 25, which is definitely smaller than 3/5. Okay? All right? 3/5 cubed is going to be 81 over 27 over 125. Okay? What's going on? As I keep multiplying this out, this is going to actually go to 0. Okay, a sub 1 is 3/5. A sub 2 is 9 over 25. A sub 3 is 27 over 125. A sub 4 is what? 81 over 725. You can see it's getting much, much smaller. Okay? In contrast, if I have 5/3 to the n, that's actually going to get much bigger, right? This is much bigger than this. So we're going to take these, we're going to put these together in one idea. The limit as n goes to infinity of r to the n, it equals, it's actually 3 cases. 0 if the absolute value of r is less than 1. 1 if r equals 1. Okay, actually there's more cases than that even. Infinity, my infinities on the iPad are ugly. I'm sorry about that. If r is bigger than 1. And then it oscillates between plus and minus infinity, divergent. We'll just not even worry about negative numbers now, okay? Or -1. Yeah, we want to worry about negative numbers. Okay, one more type of thing we'll look at. The limit as n goes to infinity, -1 to the n plus 1, n over n plus root n. Okay, that one looks interesting. Well, let's take a look at a couple. Let's write out a couple terms of this, okay? So a sub 1. A sub 1, that's n equals 1. We're going to get -1 squared is +1. So we're going to get 1 over 2. Let's write a sub 2 here. A sub 2, well, -1 cubed is -2 over 2 plus square root of 2. A sub 3, -1 now to the 4th. Okay, so this -1 to the n plus 1, I've said it before, I know, but just to remind you, it's sort of indicating a sign change. You're oscillating between positive and negative there, okay? A sub 3 is going to be -3 over 3 plus root 3. A sub 4 is 4 over 4 plus root 4. So if the -1 to the n plus 1 wasn't there, it'd be easy. That's going to go to 1. Okay? Dividing out by the highest power of n. Okay? But because of the negative, I'm sorry, because of the -1 to the n plus 1, this is going to equal, well, it's going to go to, it doesn't really have a limit. It's going to go to 2 different things. 1 for odd n, -1 for even n. This is still a divergent sequence. Okay. All right. Give me just a sec.